Hi, in this video we look at an example where we're asked to determine the coordinates of the points of intersection of each system algebraically. So we want to figure out, here we have a parabola, y is equal to 3x squared minus 16x plus 37, and y is equal to 8x plus 1 is a line. So we're going to determine the points of intersection, or the coordinates of the points of intersection, algebraically. So to do so, we can solve this system using either substitution or elimination. Here, if we call this equation 1 and we call this equation 2, well, I can sub 8x plus 1 for y in equation number 1. So I can replace y in equation number 1 with 8x plus 1, because when the line intersects with this parabola, their y values will be equal. So I can equate 8x plus 1 is equal to 3x squared minus 16x plus 37. And now basically what I'm figuring out is what values of x make their y values equal. So I can solve this quadratic equation. If I rearrange this equation and write it in standard form, I get 3x squared minus 24x plus 36. Now you can solve this by factoring, but the first thing to note is that there's a common factor, because 3, negative 24, and 36 are all divisible by 3. So common factor 3 out, and you get 3 times x squared minus 8x plus 12. Now we can factor this trinomial by saying what two numbers multiply to 12 and add to negative 8, and the answers are x minus 6 and x minus 2. So the solutions to this equation are x is equal to 6 and x is equal to 2. Now, those are the x values that make their y values equal, but we want to figure out what the coordinates are for these, what the corresponding y values are for these x values. So I can take x is equal to 6 and I can plug it into either equation 1 or 2. It's a little bit easier to calculate what y is if we plug it into equation 2, and we're going to do the same thing for x is equal to 2. So we're going to say if x is equal to 6, well, that means that y is equal to 8 times 6 plus 1, which is equal to 49. If x is equal to 2, y would be equal to 8 times 2 plus 1, which is equal to 17. So therefore, the points of intersection are 6, 49 and 2, 17. Now there's something to notice here, is that when we set up this system of equations, if we looked at the discriminant here, if we looked at the discriminant of 3x squared minus 24x plus 36, the discriminant would be b squared minus 4ac. And notice that if I did negative 24 squared minus 4 times a, which would be 3, times c, which would be 36, that would give me a value that's greater than 0. So if we want to test how many solutions or how many points of intersection there will be to a system of to a linear quadratic system, we can use the discriminant to figure out how many solutions there would be, or sorry, how many points of intersection there would be without actually solving. So I don't, just to figure out how many points of intersection there would be, I don't need to go through the whole process of solving. I can just set up the system of equations, write it in standard form, and then look at the discriminant of that equation in standard form. So I would look at the discriminant of this guy, and if you did, again, if you did negative 24 squared minus 4 times 3 times c, which is 36, you'd find that this value would be greater than 0, and that tells you that that there would be 2 points of intersection to this linear quadratic system. Let's look at another example. In part B, we've got y is equal to 1/2 x squared plus x minus 3/2, and y is equal to negative 3x minus 19/2. So again here, let's relabel these equations. Let's call this equation 1, and let's call the second equation equation 2, and let's say sub minus 3x minus 19/2 for y in equation 1. And if we do that, well, we get negative 3x minus 19/2 is equal to 1/2 x squared plus x minus 3/2. So really what we've done here is when we equate their y values, and we get this equation, we're finding out what values of x make the y values for these two equations equal. So now we can actually solve for x, and that'll tell us the x values for when this line intersects this parabola. So let's go ahead. We can first rewrite this in standard form. So if I add 3x to both sides of this equation, and I add 19/2 to both sides, I get 0 is equal to 1/2 x squared plus 4x negative 3/2 plus 19/2 is positive 16/2, which is positive 8. So I get 0 is equal to 1/2 x squared plus 4x plus 8. Now, there's two different ways that I can make the algebra a little bit easier here, because I've got this fractional coefficient. I can common factor this this fractional coefficient out, and I can write this as 1/2 x squared plus 8x plus 16, plus 16, where all that I've done is I've just divided each of these terms by 1/2 to common factor it out. The other way to do this would just be to multiply both sides of the equation by 2, and you would have gotten 0 is equal to x squared plus 8x plus 16. Either method is an appropriate way to make the algebra a little bit simpler. So now we can factor x squared plus 8x plus 16. Well, this is a perfect square trinomial because 16 is a perfect square, x squared is a perfect square, and if you multiply x times 4 and double it, you'll get 8x. So this factors to x plus 4 squared. Now, notice that this results in a double root. We get x is equal to minus 4 is the only solution to this equation. So we have two equal roots in this case. Now we have to figure out what this is the x coordinate for the point of intersection. To figure out the y coordinate, we're going to sub x is equal to minus 4 either into our quadratic equation or our linear equation. So let's sub it into our linear equation because it just makes the algebra easier. So we're going to sub x is equal to minus 4. We'll say sub it into in y is equal to negative 3x minus 19/2. And if we do that, we get y is equal to minus 3 times negative 4 minus 19/2. Well, negative 3 times negative 4 is 12. So I've got 12 minus 19/2. 12 can be rewritten as 24/2. 24/2 minus 19/2 is 5/2. So therefore, the POI is negative 4, 5/2. So in this case, the line y is equal to negative 3x minus 19/2 is a tangent line to the parabola because it's resulted in one point of intersection. So in the next video, I'll show you what the solutions look like. Another thing to note is if we look at the discriminant in this case, if we would have looked at the discriminant b squared minus 4ac of this equation right here, so if we looked at the discriminant of this equation, we would have seen that b squared minus 4ac is equal to 0. And you can do that calculation on your own. So in this case, the discriminant tells us that there's only one point of intersection. Because b squared minus 4ac is equal to 0 tells us that there's only one solution to this equation, and thus there will only be one point of intersection. If b squared minus 4ac is less than 0, well, that would have meant that there would have been no points of intersection. And we would have seen that there would be no solutions to a quadratic equation like this one. So we'll look at some more examples in the next video.